So we have this idea of a mole to a mole relationship. And that mole to mole relationship is seen in the coefficient that is in front of each element, substance, or compound. In this particular situation, we have 2 in front of the water, meaning that we have 2 moles of water. We have a 2 in front of the hydrogen gas, meaning we have 2 moles of hydrogen gas. And we have an understood 1 in front of the oxygen gas. I wrote it in so you could see it. And that shows our relationship. So let's write this relationship. If I asked you what the relationship in moles was between water and hydrogen, you would say 2 moles of water for every 2 moles of hydrogen. If I asked you what the relationship was between water and oxygen, you would say 2 moles of water to every 1 mole of oxygen. And what if I asked you for the relationship between the hydrogen gas and the oxygen gas? You would say 2 moles of hydrogen gas to every 1 mole of oxygen gas. So that is, I like to kind of put this in parentheses because it looks like a 10 otherwise. So now I'm going to actually give you a real problem, and we'll be using this relationship to solve it. So the real problem says, how many moles of hydrogen gas and oxygen gas are produced from the decomposition, I'm just going to write decomp because I'm tired of writing, of 6 moles of water. So that is changing the given from what you can see up here. But this is the equation you're going to use for these molar relationship conversion factors that will allow you to solve this problem. So I'm going to move this up because I don't have a huge screen, unfortunately, with this Screencast-O-Matic. All right, so how many moles of hydrogen and oxygen gas are produced from the decomposition of 6 moles of water? Let's set the problem up. Once again, write your given first. 6 moles of H2O. We're going to solve them one at a time. If I have 6 moles of H2O, I want to know, let's do hydrogen gas first. How many moles of H2 do I have? Given this decomposition formula, I'm going to use the relationship up here that compares moles of hydrogen gas to moles of water. So here is that conversion factor that I'm going to use, only I don't want water in the top. What do I want in the top? I want H2 in the top to give me my answer versus 2 moles of water. And when you solve this, these are actually going to cancel out, and your answer is going to be 6 moles of hydrogen gas. So 6 moles of water produces 6 moles of hydrogen gas. Now let's solve for the water versus the oxygen, and that's going to be a 2-to-1 relationship, which I'm not going to be able to keep on the screen. You know what? I'm going to just, hold on, have another idea. Let's do it this way. Okay. Now we're going to solve for oxygen. All right, so once again, we write our given 6 moles H2O. I want to get moles of O2 in my answer, so I keep looking at my want. And then I use the relationship, which is up here. And here I'm going to say for every 1 mole of O2, I started with 2 moles of hydrogen. Of water. Alrighty, so now we multiply 6 times 1 and divide by 2, and we're going to get 3. So you can clearly see that when you do a decomposition of water, you'll get 6 moles of hydrogen but you're only going to get 3 moles of oxygen. And this is how this information is used in the industry all the time.